Dora opened a savings account and deposited $50. When she gets her paycheck each week, Dora will put $25 into this savings account. Describe the initial value and the rate of change for this equation. Now, initial value. I will also get tired of writing this. You need to know I abbreviate this as IV. Initial value. Now, I told you initial value is something that happens one time. Okay, it's a one-time event. And it's usually at the beginning. Dora opened her account and deposited $50. So what did she start with? $50. So her initial value was $50. And it is her beginning deposit. So she opened up her account with a beginning deposit of $50. Now, the rate of change, I also have an abbreviation for it. It's very clever. ROC, rate of change. The rate of change is the pattern. It's what is happening from week to week to week. Okay? The rate of change happens over and over and over again. Okay? It's something you can track. Now, it can be increasing, it can be decreasing, it can be constant. When Dora puts $25 into the account, she is going to increase her balance. Okay? She's going to add or increase her balance by $25, and it is happening every week. Okay, it's happening every week. Notice how the initial value stands alone because it only happens once. It's a constant. The rate of change is going to happen over an increment. Okay, it's going to happen every so often. It's going to happen each week. We could take this, we could write an equation. Her balance, okay, her total in her account, her output, her Y, is equal to the $50 she started with plus $25 each week. And you would multiply $25 times the number of weeks and then add $50 to it. And you would know how much is in her account. Okay? If she's going to save for a year, that would be 12 months, right? $25, now that's per week. I was doing months. Let's do for a month. $25 for a month. So 4 weeks in a month, 25 times 4 is 100 plus her $50. So at the end of the month, she's got $150. It's usable. It's predictable. We could figure out 52 weeks for a whole year if we wanted to. This is an equation that comes from the pattern she established. All right, interpreting and comparing rates of change, top of page 60. We're going to talk about some maple trees, and we are going to compare initial values and rate of change. Now, in your video, I gave you a couple examples of this to write down. You actually had to find the same initial value and the same rate of change in 2 different formats. There is a third format that we're going to do in the next lesson. What I need you to understand about comparing, it's just like when I told you how to compare real numbers. If you're going to compare something, you need to put it in the same format. Now, understand there are more than one option for same format. Okay? We could compare a graph, we could compare tables, we could compare a verbal description, we can compare equations. Now what they're going to do is they're going to give you a couple different ways to see something, and they're going to expect you to compare those. You've got options. Pick a format you like and that you're comfortable with, and put them all in the same format. Okay? It's flexible unless they come right out and say, oh, you have to make a graph. I don't care if you make a graph or not. Okay? Pick something you're comfortable with and go with it. Now, in this problem, a biologist studied the growth of 2 different trees over a 5-year period. At the beginning of the study, guess what? At the beginning should tell you something. Okay? At the beginning of the study, She measured each tree's diameter. The biologist took this measurement each year to determine the growth. So one thing is happening in the beginning, right? Another thing is happening each year. One of those is the initial value, okay? The beginning, in the beginning, that's your initial value. The each year part, that's going to be your rate of change. Now, they're going to give you that in two different ways. The red maple, in her study had a starting diameter of 4 inches. Well, if that's where it started, that's your initial value. The red maple had an initial value of 4 inches. The diameter grew, there's another key word, grew at a rate of 3 inches per year. That's going to be your rate of change. Now, because it grew, that should tell you that it is increasing, which is positive. Okay, so our rate of change is going to be positive. And they gave you the rate of 0.3. So our initial value, 4 inches, our rate of change, plus 0.3 inches. That is called a verbal description. Okay, they're going to tell you something. You are looking for two things, the initial value and the rate of change. Now, the second tree, the silver maple, is on the graph. She's not going to tell you anything about it. She just made you a graph. Now, graphs are great if you can read graphs and if they are in a good, usable format. This graph is okay. It's not bad. The graph that you have to make for the red maple, it's less useful, okay? Sometimes graphs are not useful. Sometimes they're amazing. Now, if I want to compare my verbal description to this graph, I have options, okay? I could take my graph, I could make a verbal description. I could take my verbal description and I could make a graph. We are going to do both. If you want to make a graph, you can make a table of values, okay, just like we did on the last page where we filled in the blanks. That's what you're going to do here. You can use a graph to show the rate of change for the red maple. Make a table of values. At the beginning of the study year, 0, the diameter of the red maple is 4 inches. Its diameter grows at a rate of 0.3 inches per year. Now remember, your rate is your pattern. The initial value is where we start. Year 0, it was 4 inches in diameter. Now, the rate of change will start at that 4 inches, and it's going to be a pattern that repeats. We are going to add 0.3 each year. So 4 plus 0.3 is 4.3. Then the second year, we add 0.3 again, giving us 4.6. The third year, we add another 0.3 to get 4.9. Then we get 5.2 by adding 0.3. And then add 0.3 to get 5.5. This is our repeatable pattern. That was our initial value. Now, once you complete the table, you can put it on a graph. Now, once they're both on a graph, that's usable, right? We have both pieces of information as a graph. Now, I want you to think about this really quick. By looking at these two graphs, this one's up here, this one's down here. Is it really easy to say anything about those graphs with them separated? It's really not. Okay? If you want to compare your two graphs, put your graphs on the same graph, just like on your graphic organizer. That way you can see where the initial values are and you can compare the rate of change. Okay? They're going to be right there, same spacing, everything's going to look the same, but you're going to be able to see the differences better. Okay? This is okay, but it's better if they're together. Okay? It's better if they're together. Top of page 61. Number 2 says, which ordered pairs, write the ordered pairs for the points that show the initial value on each graph. Now, the initial value, your starting amount. They want an ordered pair. Your starting amount will always be 0 for x. Now, for the silver maple, it was on the graph. They didn't tell us that information. When x was 0, y is 3. Okay, our initial value is here on the y-axis at 0, 3. Now, the red maple was our verbal description. They told us the initial value was 4. When x is 0, at 0 years, that tree was 4 inches. If you're looking at a table, that ordered pair is here. When x is 0, y is your initial value. What does the initial values represent in this problem? Okay, it was the starting or beginning diameter for each tree. Now, number 3 is going to show you how to compare rate of change. Before we go on, which tree was bigger in the beginning? Yeah. It was the red maple. Okay, the red maple. The silver maple was 3 inches. The red maple was 4 inches. So let's just go ahead and label that. This one was larger at the beginning. Okay, it was bigger at the beginning. Now, let's talk about rate of change. Fill in the blanks to describe the rate of change for both functions. Now, I told you guys about delta y over delta x. Our vertical change, how much it went up or down, it increased 0.3 inches for each year. So 0.3 over 1 was the rate of change for the red maple. Now, the silver maple, they did not give us the rate of change. We have to calculate that. So if I slide over here to my graph, I'm going to zoom in a little bit so it's a little bigger for you. We are talking delta y over delta x. Now, you want to pick 2 points that you know the ordered pair for. The first one is easy. We already know it's 0, 3. Now, these are not good points, but this one is exactly halfway between 4 and 6, which would make it 5. So at x, at year 5, it was 5 inches in diameter. Now, if we want to calculate the change, remember delta y, change in y. From 3, remember y's are the second number. From 3 to 5, how much change is that? Plus 2 or minus 2? Positive 2 is our change in y. My change in x, how much from 0 to 5? 5. Plus or minus? Plus 5. So our rate of change for the silver maple is positive 2 over positive 5. Now, we don't want to compare a decimal to a fraction. We need them in the same format. If I divide 2 by 5, I get 0.4 over 1. Now I can compare my trees. The red maple is growing 0.3 inches. The silver maple is growing 0.4 inches. My silver maple is growing faster. Okay, the silver maple grows faster. Now, it was the smaller tree at the beginning, but it's growing at a faster rate. Depending on how much time I have to wait for that tree to grow, I would prefer to have the smaller tree that grows faster. Okay, I want a fast-growing tree, so I have shade in my yard. I've had my yard for 15 years, and I still have no shade. What do the rates of change represent in the problem? Rate of change is the inches that it grows each year. Okay? Inches per year. The number of inches that that tree grows each year. That's your rate of change. Look at that. It's not pausing. It's not pausing. There.